Hello everyone, today we'll talk about the solution of the problem continuous subarrays. When looking for some standard observations that we can make, the first thing I'd like to maybe point to is that there was recently a daily that was very similar to this, but it was not asking us for subarrays, so contiguous subsequences, but just for a subsequence, and in that case we just sorted the array and that made the solution much easier. We cannot do that sorting here because we are only interested in subarrays, in contiguous portions of the original array, and if we change the order of elements, then we forget the information about which element was next to which other element. So we cannot do this, but another observation that still works here is that, of course, since this condition, which essentially means that the maximum minus the minimum cannot exceed 2, so they have to be close together, is monotonic in the sense that if we have a good subarray, then every subarray of that good subarray is also good. And that is the typical condition which makes using two pointers viable. Because if we can, for instance, for every right end of a subarray, find the furthest to the left end, then this will give us the longest subarray that ends at that position, and then counting all of the good subarrays is very easy at that point. However, here, if we try to do it naively, we'll find that it presents some problems, because let's say that we remember the maximum and minimum within our sliding window. We push the right end forward, and at some point the window breaks. The difference becomes too big. Well, we have to push the left end forward then, but we don't know how far, because if, for instance, we skip an element, we don't know if that element was one of those maxima or minima that actually breaks our solution, if we should throw it out or not, because we don't know what remains within our subarray. And we can try to deal with that, try to maintain that list of elements within the sliding window. That's not too difficult, and that is one possible solution. But there is also one trick that can be used here to not use any data structures and still use a sliding window, or rather a two-pointer technique. And that idea is that instead of, when the window breaks, pushing the left end forward until it's good again, we can start with a window that's definitely good, which is just the window containing only the right element, and push the left end to the left from that position. And that might sound a little suspect, but let's first start with its correctness, which is pretty easy to see that this is correct, because we start with a good subarray and we just push the left end to the left until we almost break the window, right? If the window breaks, then we stop pushing the left end to the left. And for it to still be essentially considered a two-pointer technique, we know for sure that the left end will only be going to the right in increments of 1, so that part is simple. But what about the left pointer? And the idea of the left pointer is that the left pointer is only going to be doing two different movements. One movement is one step to the left, and that's the suspicious movement. The other movement is jumping to the right, to the element that we're currently looking at. And it's easy to see that when we jump to the right and then push the pointer to the left, we cannot exceed its previous position. And that leads us to the conclusion that it again will be moving to the left, but it will only pass through a single element at most once, which is the important part for the linearity of the two-pointer solution. And of course, to count the number of contiguous subarrays, because this will lead us to finding the maximal subarrays that we can get for every end, we can either count them for every end separately, or we can count the number from start to finish of all the possible subarrays, and then we'll have to essentially use the inclusion-exclusion principle to make sure that we don't overcount any arrays. So essentially, when we see that we're overcounting something, we'll have to fix it. For length of L, we have L times L plus 1 divided by 2 different subarrays, because this is just the number of pairs of ij, where I is less than j. And here, by the way, I append some value like -2 to the end of the array, because we're only going to be counting the number of subarrays when the window breaks, so we want to make sure that at the very end the window breaks. So this is this sentinel value. We will maintain the maximum and minimum on our sliding window, and of course this is the left pointer I, this is the right pointer j, and whenever we push the j pointer forward, we update low and high, and now if high minus low becomes greater than 2, so the window has broken, we first add everything that we can make from this window before it broke to the result. And now we'll be pushing the left end, starting from the left of our position. And of course we have to remember to update minimum and maximum to this smaller window, so this is just the current element. We'll be pushing the left end to the left for as long as the window is not broken, and of course updating the low and high values. And at the end I will be pointing to the first position where the window would break, or maybe it will be equal to -1 if everything is okay. Then we just add 1. Now I is the last good position, the leftmost good position, and we have to fix the result by subtracting the length of the subarrays, or the number of subarrays that are overcounted here. That's because we do not want to count those arrays, they were counted already in this point, so we have to subtract them by looking at this new pointer I, to not double count them. And at the end, of course, we return the result.